Hello everyone, and welcome to our last video in this particular section. Today I took Miss Idstein's notes and I put them into a flip chart because that will allow me to write a little bit easier. I thought that might work out better for us for today. So today we're going to take our factoring and we're going to add something to it. Today we're going to be solving. So if you think about that word solve, anytime we solve an equation, we come up with an answer like x equal to a number. And that's the way our problems are going to do today. The method that we're going to use to solve is factoring, but the factors are not going to be our answer. Today we're going to add in this extra thing of solve. And you can see that she has ZPP on your paper. So ZPP stands for zero product property. She just took the first letter of each of those and turned it into an acronym. So zero product property. So what we're going to do today, very similar to what you guys have been doing, we're going to find the GCF of the problem that we're given. Then we're going to factor using one of our 5 factoring methods. And then the new part is here in step 3. We're going to use the zero product property, and our answers are going to be an ordered pair. We're going to write the zeros that we find as ordered pairs. Okay, so that word zeros. You might remember from what we did on the calculator that 0 is what the calculator calls the x-intercepts. So what we're going to be doing today is we're going to use factoring to solve and find the zeros of a function, which are also the x-intercepts, also called the roots. And because you see the word solve in here, sometimes those are also just called solutions. So for our purposes, these 4 things are synonymous. You could see any of those words in the directions for the homework, in the exit slip, in the quiz, in the quizzes that Ms. McHugh created. Any of those things could be used to identify this same thing, which is the x-intercept. Okay, so the first problem she's got for us, x squared minus x minus 2. All right, first thing we want to do is see if we can identify the GCF. Well, I look across there, x squared, x, and 2. The only thing they have in common is 1, so I don't need to factor out a GCF. And then I'm going to factor. Okay, so let's see what we can do to factor the trinomial that's over here on this side. So I see my A is that understood 1, C is negative 2. So AC is 1 times negative 2, which is negative 2. So I need 2 things that multiply together to be negative 2 and add together to be negative 1. Remember, we always try to add to be B here in the middle, that understood 1 in this case. So the numbers that I'm going to come up with, negative 2 and positive 1, they add together to be negative 1, multiply together to be negative 2. So I'm going to replace that in the middle, minus 2x plus 1x minus 2, and I'm going to keep that equals 0 on the end there. We don't need that until the end of the problem, but we're going to leave that there so that we can not forget that we're supposed to do that part. All right, so now, just like we've always done in class, I'm going to cut that in half right there. And then I'm going to factor each side separately, finding the GCF of each piece. So for those two, the GCF is x. What I have left in the parentheses is x minus 2. For these second two, the GCF is 1, so it might be tempting to leave out the 1 because it's understood, but it actually is going to help the next step a lot if you go ahead and write it. Again, I've still got that equals 0 right there. What's in the parentheses is the same, so I'm going to put those together as x minus 2, and what's outside the parentheses, x plus 1, goes in the second one. Okay, so now what I have found are the factors. X minus 2 and x plus 1 are the factors of this original trinomial. If I multiply them back together using FOIL or the double distributive property, I'll get this. So now I have to do the solve part. The directions said solve by factoring. I've done the by factoring part, so now I need to solve. So that's where my zero product property is going to come into play. Anything that has an x in it, I need to set equal to 0. So the zero product property basically says if I have 2 things multiplied together to be 0, which in this case I do, this one times this one is equal to 0, then either the first one equals 0 or the second one equals 0. Because 0 times anything is 0. So one of those at least has to be 0, maybe both. All right, so let's solve. The one on the left, I'm going to add 2 on both sides. And I get x equals 2. The one on the right, I'm going to subtract 1 from both sides. And I get x equals -1. So those are the solutions to this quadratic that we have right here as an equation. We can see it's an equation because it has an equal 0. And now the last thing I want to do is write those as ordered pairs. So if I take this and I remember that my zeros find for me the x-intercepts, well, I remember that for the x-intercept, y is always 0. That's why we have this 0 right here. And on this one, I have -1, 0. All right, so I went into Desmos and I graphed this one for us. And you can see that when you look at the graph, the zeros or the x-intercepts or the roots are -1, 0 and 2, 0. So this really does fit with the graphing that we did before. It helps us to find these x-intercepts once I put that equals 0 on there because the y value of both of these points is 0. Okay, let's go to the next one. So I've got 2x squared minus 5x equals -2. Well, automatically this one looks different because I have a -2 over here, and what I had in the last one was an equals 0. Well, if I want to use my zero product property, I have to have a 0. Anytime we try to solve a quadratic, and remember this is called a quadratic because of that exponent of 2, anytime we try to solve a quadratic, we need it to be equal to 0. So the first thing I'm going to do is add 2 on both sides. And that gives me the equals 0 that I wanted. Okay, now I can come over here. I need to find the GCF. Well, just like last time, when I look across this, I don't see anything that will go into all 3 of those besides 1, so there's no reason to factor out a 1. Step 2 is to factor. Well, again, I see that I have a trinomial. Anytime I have a trinomial, I'm going to do A times C. In this case, A is the 2 in front of the x squared. Sorry, that one's not understood. And C is the 2 here at the end. So I have 2 times 2, which is 4. So I need two numbers that multiply to be 4 and add to be -5. Well, I know that 4 and 1 will give me 5, but I need a -5. So I need both of those to be negative in order for that to work. So -4 times -1 is +4. -4 plus -1 is -5. Okay, let's substitute those in. So I'm going to get -1x minus 4x plus 2. You can put them in the other order, it doesn't matter. All right, now I'm going to cut that in half, just like we usually do. And then I'm going to factor the GCF on both sides. So 2x squared and x, well, I see those have an x in common, so that's going to come out in front. And what I have left in the parentheses, 2x minus 1. All right, and I noticed that with this, I have a positive 2x and a -1. Well, that's exactly the opposite of what I have here, negative and then positive. So when I factor out my GCF here, I want to be sure to factor out a negative so that I can change the signs. Positive 2x minus 1. All right, 2x minus 1 is the same in both parentheses, 2x minus 1. And what I have in the front, x minus 2, goes in the second parentheses. And remember, we looked at in a previous video the fact that both of these are now linear. Both of them have an x to the first, which is what I wanted so that I can set each of them equal to 0. I'm trying to create linear factors. I'm going to take this quadratic with the exponent of 2, factor it to make it linear pairs. All right, now once I have it factored, I can use my zero product property, ZPP, to set each of them equal to 0 separately. If two things multiply together to be 0, then either this first one equals 0, or the second one equals 0, or perhaps both. So on this one, I'm going to add 1 to both sides. I'm running out of room, so I'm not going to write that. And then I'm going to divide by 2 on both sides. X equals 1/2. On this one, I'm going to add 2 to both sides. X equals 2. Oops, my equals didn't show up. So now I'm ready to write my answer as an ordered pair because what I have actually found here are the x-intercepts, and those x-intercepts are going to be 1/2 comma 0 coming from the first one, and 2 comma 0 coming from the second one. So again, I went into Desmos and I graphed it, and you can see my x-intercepts here, 2 comma 0 and 0.5, which is the same thing as 1/2 comma 0 on this one. Okay, let's do another one. All right, so let's look at this one. This one I can see is a little bit different. I only have 2 terms instead of 3, so we're going to have to use a different factoring method. But still, that first step, if I'm going to use the zero product property to solve, I have to have a 0. So I'm going to subtract x on both sides. 9x squared minus x. Those are not like terms, right? So I can't put them together. One of them's x to the second, one of them's x to the first. I can see that I still have a quadratic. I have an x squared there, but I only have 2 terms. Well, when I have 2 terms, I don't use a times c. That's for when I have 3 terms. So this one is going to be a little bit different. I am going to start off with the GCF, just like we always do. Well, I can see that both of those have an x, so I'm going to factor out an x. I'm going to get 9x minus 1. Remember, x divided by x is 1. Don't forget to put that second term in there. I've still got the equal 0. That can't go anywhere. All right, now look, this one is linear. This one has an x to the first. This factor does. This one is x to the first. This factor is also linear. So I don't have anything left that I can factor any further. I've gone as far as I need to, and now I can use, my zero product property, and I can set each of those equal to 0 separately. X equals 0, 9x minus 1 equals 0. Well, x equals 0 is already solved. There's nothing left to do there. I already have x by itself. So I'm going to write my ordered pair as 0 comma 0. In the second one, I'm going to add 1 to both sides. 9x equals 1. Divide both sides by 9. Like last time, I'm not going to write it down just because I'm running out of space. And so 1/9 comma 0. So if we look at the picture from Desmos, you can see that I have 2 x-intercepts, 0, 0, which was this first one, and 0.1 repeating. That's the same thing as 1/9. If I were to type that in my calculator, I would get 0.1 repeating. So 1/9 comma 0 is this one. So again, those are those factors give me my x-intercepts, also called my zeros, also called the roots of the equation. And because we're solving a quadratic, they're also called the solutions. So be very familiar with those 4 words when you guys take the quiz on Friday. All right, we're going to stop this video and we'll do another couple problems in another video, and then we'll be done for today.